Hello, anatomy and physiology kids. This is intended to be a review for those of you that need it, but mostly we had a lot of people out with flu right before school ended, so I know a lot of you missed the opportunity to go through this as a class. So, this is an overwhelming page, but this is your specific defense, and it kind of works like your non-specific defense. And your non-specific defense, something came along and the macrophage identified it. And if it was self, it let it go. If it was non-self, it engulfs it. And once it engulfs it, instead of doing like it did with the non-specific defense, instead of just destroying it, it's going to go and present it. It's going to go and basically sound the alarm that there's something foreign in the body. And so it's going to become an antigen-presenting cell, and it's going to go and tell the helper T cell. And the helper T cell has to decide, is this extracellular or is it intracellular? And extracellular basically means that something from the outside the body, something like bacteria or just something that's outside the cells. And intracellular is more your viruses and tumors, or it could be cells that have gone rogue, cells that have mutated. And I also put viruses in there because, as we talked about in class, viruses can actually take over the DNA of your actual own cell. And so it can present itself as if it's one of your own cells. All right, so the helper T cell has to decide, have we seen this before? And is it extracellular or intracellular? If it's extracellular, it's considered a humoral response. If it's intracellular, it's considered to be cell-mediated. If we've never seen it before, it does not go through memory. If we've seen it before, it goes through memory. So I'm going to say that it's extracellular, and I've never seen it before. It's going to activate the B cells. The B cells are then going to activate plasma cells while making memory cells, so that the next time you encounter it, it happens faster and faster and faster. The plasma cells are going to make antibodies. The antibodies, it'll make a whole bunch of antibodies, and they'll go and fight. But keep in mind, the antibodies are weaker. It's a weaker response, but it is there, and it will fight. But it's kind of like tiny ants working together to take care of a problem versus like a powerhouse big item. All right. If the helper T cell says, it's actually cell mediated, it's intracellular, and we've not seen it before, it's going to activate cytotoxic T cells. And those cytotoxic T cells are going to become active, and then they themselves are going to go and fight. These guys are powerhouses. They're big, they're strong, they can take care of some things. But while it's doing that as well, it'll also make memory. This first response, when it's never seen it before, is really slow because it has to make B cells that can make plasma cells and antibodies that are specific to that bacteria, or it has to make cytotoxic T cells that are active towards that specific virus or mutation. So important to note that if it mutates in any way, it starts all over. The process starts again, and it's as if it's never seen it before. However, if it has seen it before, it goes through memory, and then memory goes ahead and activates the memory B cells that already know how to fight it and make plasma cells and antibodies, or it'll activate the memory T cells, and then they'll become active and go and fight it. The second time you see something, it works faster. The third time you see something, it works even faster. The more times you see something, the faster and faster the response is, to a point where you can actually encounter something and never ever show any response to it. So that's kind of why we do vaccines. Vaccines put a little bit in the system, not enough to make you sick, but a little bit in the system to build these memory pieces. And a lot of times vaccines have to be boosted. So you have to see them, you'll get them more than once. And it's just to put a little bit in the system and create a little bit of that memory. But keep in mind, any mutations the whole system starts from scratch again. So it's kind of cool that our bodies can remember it and can move forward and go through this process. I know this was a lot. You may have to watch the video more than once. It's not a super easy process, but you can work through it. Some of you still have these things that we made, and some of you that weren't in class may want to make the pieces of this process into little something manipulative that you can move around. Because if you make something like this, you can typically move it around and practice it over and over and kind of talk through it, and it tends to work a little bit better. You do want to know before next week, you do want to know this process, because we will be doing a open book test, but it's different. It's set up differently, and it's going to really rely on you understanding the material, not just being able to look it up.